Thank you very much. First, I'd like to welcome you to the 48th Design Automation Conference. Thank you for joining us for the first session in the Chip Estimate IP Talk series. I want to talk today about some of the things ARM is doing to provide innovation and help to continue the drive in the industry we've seen in these recent years. And I want to start by setting the background a little bit. If you look at the world and the markets we're seeing in electronics today, it's becoming increasingly connected. And ARM is the heart of a lot of these devices. Just in Q1 alone, 1.8 billion units were shipped with ARM-based devices, and 1.1 billion of those in mobile devices. You're also seeing some interesting trends where smartphone data is really exploding. And we're seeing smartphone data we expect to exceed PC data in 2014. So phones and mobile platforms are becoming an important way for people to get information. Also, you're seeing that with 4 billion people using ARM-powered mobile phones, we're seeing some changes in e-commerce. Mobile platforms are becoming a major way for people to do commerce. You'll see some statistics here where $230 million was spent on eBay in the holiday season on smartphones. That's an unbelievable kind of thing that didn't exist in only a few years ago. But it's also interesting to look at this 1.8 billion, 1.1 billion in mobile devices. That means fully 700 million units in Q1 alone or in non-mobile devices based on ARM platforms. And that might surprise you. So today I'm going to talk about mobile devices, I'm going to talk about non-mobile devices, and I'm going to talk about next generation technologies that we call smarter systems. So here's the outline of my talk. The industry has evolved in recent years, in the past decades, in fundamental ways. And I want to talk for a little bit about what were the sources of those innovations and what can we learn about them for the future. Then I'll talk about how the markets are evolving and how reuse from one application to the other is important to continue innovation and drive down costs. Then I'll talk about some of the implementation challenges we face as these applications become more complicated and show you some of the solutions that ARM is offering to help drive those forward. And finally, we'll talk about partnership and how we believe partnership is a solution to a lot of these challenges. And if you stay with me to the end, we've got two things that we're announcing today, and you'll be the first people to hear about them at the Design Automation Conference at the end of my talk. So first, if you think back to the past decades of mobile computing, you've seen some very specific eras in mobile computing. Very specific eras in mobile computing where they had different trends. Beginning in the 60s and the 70s in the mainframe and mini-computer era, the issue was really starting with small quantities, shifting into the PC space, up into the mobile device space. And each of these generations had an order of magnitude size gain of the potential market compared to the prior generations. Going into the future, we see the market for what we call the Internet of Things, which is where devices that you're not used to seeing connected today are now being connected. You're seeing, and we'll talk more about these in a moment, you'll see it's very deeply embedded devices that are connected that weren't connected ever before. So let's look at some of the drivers behind these computing eras in the past. First, beginning with the mini-computer and mainframe era. It really began with functionality. This was all about performance back in that time frame. But as you shifted into PCs, it shifted away from raw performance to being performance delivered at a cost level that was suitable for the wide market. And so it changed the dynamic in the industry and at that same time dramatically increased the potential market. As you go into the next generation of laptops, it was all about delivering this functionality and cost, but in a mobile power envelope. And that enabled the laptops that all of us have been using for the past 20 years. But if you think about laptops, they actually have a relatively large battery. It's quite a heavy battery just in your laptop alone. Contrast that with the applications we're seeing today in the tablet space, where now tablets and smartphones have really quite a small battery. So that means you need to have a focus not only on just power, but really on power to the extent of energy, where you just want to figure out how to do the job with the least energy possible. And that's going to drive, we believe, the next wave of innovation where people have to be very energy conscious top to bottom in their designs. So we think ARM is very well positioned to drive low power into the future. And we think low power is going to be necessary in every application, not just in computers, not just in mobile devices, but in everything from microcontrollers to servers as well. And we think low power is a design philosophy. It's not just something you can bake in as an afterthought. It has to be fundamental as part of your design practices. And it's not something you just change easily. ARM, at its heart, is a power-efficient architecture. And we think that's important. If you look at what was done in the past in, for example, the PC laptop space to deliver low power, typically what was done was some portion of the manufacturing distribution that was low power was cherry-picked and sold at a premium as low-power parts. And this is a practice called speed bidding. And it was effective, and for those people that wanted low-power devices, it delivered some additional power options. But it's not a viable option to deliver a real rich ecosystem of long-term devices. So instead, ARM is supporting the development of low-power devices top to bottom, baked in as a key part of the product. So as we move forward into the future, we believe the drivers of the next generation of the Internet of Things is going to not only be about this functionality over energy, but even looking at the available energy, things like solar energy, extremely small devices, even kinetic energy, of these very, very tiny devices. We're seeing things that are wearable, where you need to have a long battery. We're even talking about applications as small that could be implanted in your eye, literally. That's incredible to think about something so small. And this is going to facilitate the ubiquitous computing where things all around us are connected. You can imagine your refrigerator telling you you're out of milk when you're driving home past the supermarket. And beyond that, the next generation after that, well, we're not really sure what the solution is going to be. Today, if you look at battery technology, it's not keeping up with the demands of the computing space, nor is charging. Charging speed is still a limiter. And that means the amount of fixed energy you can carry in your pocket is fixed to how fast you can charge your lithium-ion battery today. And that means you have to be very efficient with every joule that you're doing with your computing. So ARM is taking these kinds of applications and this market leadership we have and driving that into new applications. We're taking the mobile leadership, driving it into many different markets that you may not know ARM is in today. We're continuing to drive innovation in the automotive space, also moving into servers and enterprise, where data centers now are a significant energy consumer, and how much compute you can put in a data center is not driven by how fast your processor can be, but how much you can cool it. So it's an interesting area that we're beginning to move into in the future. We're also putting connectivity into applications like TVs, set-top boxes, and things that didn't have connectivity in the past. And so this is very interesting as we look to the future. And microcontrollers is a critical area. Microcontrollers in the past were these unsung heroes, 8-bit controllers doing very rudimentary things. But we're seeing the evolution of the microcontroller space being very interesting, where they're being put in places that you didn't see before. Things like motor control. You can actually get far more efficiency out of a motor if you align the power bursts with the rotation of the motor itself. And so you're actually seeing microcontrollers in there for power-saving applications and efficiency in motors. Very interesting. Your washing machine can save a lot of power if it has a microcontroller versus if it doesn't. The smart metering, there's a lot of news in the press about smart meters and how they're used to help distribute energy at non-peak times and monitor usage. And even in heating and air conditioning, I know the air conditioning controller in my house has an unbelievably complicated control system in it. But it's not just a nice to have. Government mandates are driving the need to put low power in devices. Things like standby power, making sure that in off-peak hours you're not using power unnecessarily. And by driving into this embedded space, ARM is taking the ability to put 32 bits controllers in the price point that typically would only be supported by 8-bit controllers. And that makes it far easier to develop software for these applications than it ever was before, letting you use modern tools and modern innovations. So we think that's very important. The total market for microcontrollers is massive. We see in 2015, I think it's 19 billion units forecast in 2015 alone for microcontrollers. So we're driving very hard to bring these across a range of spaces. Now let's move back from microcontrollers into the higher performance space and talk about the high end of the market. If you think back about 15 or 10 or 15 years in phones, the phone of that era was very rudimentary. Single processor, very basic display, no graphics, running one application, your phone. And you were glad to have it. But as we moved into the smartphone space in the mid-2000s, The early smartphones were a little bit more complicated. You had color, you had some basic graphics, maybe you had a little bit faster processing, but still it was a lockdown platform that wasn't giving you a lot of capability. As we moved into this recent decade, we're starting to see the explosion in the smartphone market, and one of the things you're seeing is applications. The application space that everybody's seeing is a very big commerce area where the applications themselves are selling a lot, but even more importantly, the applications are facilitating interesting applications, interesting interaction with users. That's very important. We're also seeing the phones themselves are becoming much, much more complicated. We're seeing phones with up to 9 processors, graphics, video engines embedded. And this complexity is both a challenge and an opportunity for us in the industry. So let me show you what ARM is doing across a wide range of technologies to facilitate this kind of innovation. On the right side, you see the apps processors, the Cortex-A series that is often talked about. These are the high-end processors that at the very brains of leading-edge mobile devices, like our Cortex-A9 processor today and our recently announced Cortex-A15 processor coming up next. And that drives the high end of the smartphone. And we're seeing now smartphones come out with multi-core in a smartphone, and that's going to continue into the future. We also have the Cortex-R series in the upper right that you see that's generally used for real-time applications, things requiring real-time deadlines like communications protocols and baseband. And that's an area where ARM has been for a long time. We're also driving very hard now on the left side into the Cortex-M series. This is the microcontroller space, where not only the microcontroller applications I talked about earlier, but also in applications like Bluetooth, the SIM card itself, GPS, power management. A lot of different areas where ARM controllers are baked into the application that you might not realize. But it takes more than just cores. You have to implement the core, and you have to tie it together. And that's where ARM physical IP comes in. This is a platform of implementation IP that lets customers implement their chip into silicon. System IP, which is bus protocols, cache controllers, and so on that our Fabric division develops for the purpose of connecting ARM cores and ARM subsystems together, and so on. All of these technologies are required for next-generation smart devices. Now, as you have a device of this complexity, I think it's very interesting to see how far we've come. Look back at the device I showed you a couple of minutes ago, your smartphone from the mid-90s. It was based probably on the ARM7 TDMI. This is the highest-selling ARM core of all time. It's sold in the billions and billions of units. Back in this generation, this was 74,000 transistors, and that was a whopper at that time. In 0.5 micron technology, it was around 4.5 square millimeters. And you know, it was relatively straightforward design by today's standards, but by then it was hand-designed, very simple, 1 voltage domain and a couple of corners. Contrast that with today, where you have a Cortex-A9 dual-core application. This is over 20 million transistors in this dual-core configuration, and it's around the same size as the ARM7 TDMI if you use today's leading semiconductor technologies around 28 nanometer. It's around, actually it's a little smaller, 3.5 square millimeters in 28 nanometer. But the difference in these processors is night and day. Of course, the performance is wildly different, but the implementation complexity is there as well. 12 different sign-off corners, power, performance, leakage, different corners you have to sign off. Multiple voltage domains so you can power down parts of the design that aren't in use. Design for manufacturability, voltage variation, many different things you have to contemplate to make this chip successful. And if you compare the ARM7 TDMI in today's manufacturing technology, it's just a punctuation mark on the side of the Cortex-A9 application. So what is ARM doing to help support the designers in achieving these very difficult applications? One of the things we're doing is developing a product called the Processor Optimization Pack. And this is a very important interdisciplinary collaboration between the processor division and the physical IP division of ARM. The goal is to support a complete package of IP necessary for our customers to implement and succeed at achieving their power, performance, and frequency goals. It comprises optimized ARM artisan physical IP, which is specifically designed for the cores in question. So this isn't generic IP that could be used to implement anything. It's additional value-added, optimized parts that help customers get to the performance and power goals they want. It also comes with ARM's benchmarking results that shows what we were able to accomplish to help our customers know what is reasonable and what is achievable. and also implementation guidelines that shows how to get there, how to duplicate these results in fast time to market and high reliability. The results are customers can optimize their designs for power and performance, get silicon-proven results faster with higher confidence. We find our customers see around 25% uptick in performance, sometimes more, depending on where they're starting from, using the processor optimization pack compared to a baseline design. Or you can use those same gains instead to reduce power, and we're seeing an 80% reduction in leakage power. These processor optimization packs will be offered at a range of high advanced technologies. Here I'm showing TSMC from 40 nanometer and 28 nanometer, Global Foundries at 32 and 28 nanometer, and Samsung as well. Here what I'm showing are the processor optimization packs available now and in the coming months, but this is just a beginning of the rich roadmap we'll have going on into the future in new process technologies and new ARM cores. To show you an example of how these processor optimization packs dovetail with our physical IP platforms, let me show you the roadmap. Well, let me show you an example first from TSMC. Here's an example of the potential for the processor optimization pack to improve your application. Customers in 40 nanometer have told us time and again, we would really like to get to a gigahertz performance on 40 nanometer. And if you use a baseline implementation methodology, it's very difficult to get there. Customers using out-of-the-box implementation style will get probably around 750 or 800 megahertz with a basic implementation. Using the processor optimization pack at nominal voltage, we see people getting in the high 800 megahertz range. And if customers use overdrive, they're able to get over a gigahertz and sometimes a bit more than that. Those customers who want to use typical silicon to show their customers what's possible are able to get even higher as well. So this is a substantial uptick, and it's enabled our customers to reach the over gigahertz point that they've demanded from the marketplace. Now let me show you how this lines up with the roadmap. For TSMC, Artisan Physical IP has a rich roadmap spanning 40 nanometer all the way to 28 nanometer and beyond. And the processor optimization pack is really the crown jewel on top of these platforms. These platforms are physical IP of logic, memory compilers, I/O, and DDR interfaces. And the processor optimization packs augment that with specific tuning and IP for ARM cores. But we're also collaborating across the industry as well. Here's a collaboration with Global Foundries in the same way, starting at 65 nanometer all the way to 28 nanometer and beyond. So focusing not only on low power platforms, but also high performance platforms as well. And while I'm not showing it in this presentation, we have a similar platform for Samsung as well, which is a very strong partner with ARM. So today, I want to tell you that just processors, just implementation technologies for physical IP isn't enough. You also need to connect things together. And one of the important things that ARM develops for our customers is system IP that forms the bus infrastructure inside an SoC to connect the components together. And today at the Design Automation Conference, we're announcing the next generation of our AMBA 4 bus interconnect specification. And this is the cache coherent interconnect specification for AMBA 4. We call this ACE for AMBA coherency extensions. And this is very important for our customers as they develop these advanced applications featuring different kinds of technologies. If you see on the right here, there's an example block diagram. You can imagine this is an example with 4 Cortex A15 cores times 2. So this is a total of 8 Cortex A15 cores in this block diagram, connected with a coherent interface. It's also showing our Mali graphics interface, which also has to be coherent because the CPU is going to generate some graphics data and it needs to get it over to the graphics unit, so you need coherency. In the same way, you may have I/O devices that are coherent as well, and on the bottom side, other DMA engines as well. So what the coherency extensions we're announcing today provides is a consistent framework for our partners to develop cache coherent interconnects that can plug in to the AMBA 4 specification. For those customers that want to use ARM's implementation, you see in the middle the CCI 400. This is ARM's implementation of this specification, the cache coherent interconnects. And that'll be available for those customers who want to use that now, or customers can implement it themselves. But the result is a tightly coupled memory system that has quality of service, cache coherency necessary for the next generation of applications, high utilization of the memory interface, and things like virtual networks, which are necessary when the applications get to be as complicated as they are today. That allows data to pass other data in the network and avoid blockages. So this is a key announcement. But we're not stopping there. To continue to drive innovation and pull together the different kinds of technologies necessary to implement SOC, it requires an interdisciplinary view. So today at the Design Automation Conference, ARM is announcing the next in the series of ARM's communities on ARM.com. These have been very successful communities for the past few years, focusing on applications like software, embedded, multimedia, and so on. And what we're doing is extending those communities with a new one called the SOC Design Community. And the goal here is simple, to provide an ongoing resource to ARM-based SOC designers by providing them news, information, best practices, specification updates, training, webinars, a wide range of things in one place. This is designed to be a place you can bookmark, come back to again and again and again, and always find interesting information. It's on the web now. It's at arm.com/community/SOC. We encourage you to check it out, and we encourage you to come back regularly. And this is not only about any one technology. The key point is it's about a wide range of different ARM technologies and best practices from the industry, outside technologists as well. So in summary, we believe it's about partnership. Partnership is the key to delivering smarter systems into the future. It begins first with the internal expertise and requirements from our customers, continues with the processor, graphics, and system IP from the ARM processor division, continues with artisan physical IP to help our customers realize these chips in fast time to market, high performance, and low power, continues with the process technologies from our foundry partners that I've mentioned earlier, and finally with EDA flows and implementation methodologies from our EDA partners. And the sum total is a very rich ecosystem of leading edge applications. But in case you think we're at the end of this roadmap, we're not. We're just at the beginning. There are 6.8 billion people on the planet, and 1.4 billion of them don't have electricity. 2.2 billion of them don't have a mobile phone. Well, that means there's a hell of a lot of mobile phones out there. But if you look at the next bullet, 5.1 billion of them don't have internet access. And that means even the smartphones that we take for granted, there's a lot of penetration still to come to get internet access into the developing world. And one of the things I mentioned earlier is smartphones are becoming a way that people are getting internet access instead of wired landline applications in places where landline wiring is prohibitive. So this is a very interesting way that we think the market is evolving, and there's billions and billions of units in front of us in the marketplace. So we think, aside from just mobile, in general, ARM has an abundant opportunity. The last data that was published is in 2009, that ARM has 28% of the market of all microprocessor shipments worldwide. And that's growing. Over 20 billion units of ARM cores shipped to date, and as I mentioned, Q1 alone, 1.8 billion units shipped. We see a path easily to over 100 billion total units shipped over the next 10 years, and the reality is that's probably a conservative number. So huge growth in applications, and it spans everything from the mobile phones I talked about all the way down to microcontrollers, where different technologies are needed for success into the future. So our challenge to you, the ARM partnership, and the electronics industry in general is to continue to demand great things from us, bring your requirements to us, and show us what we need to develop for the next generation, and we'll continue to deliver a wide range of technologies that makes that possible. So I want to thank you for coming and seeing us, and please visit ARM on ChipEstimate. We hope you'll consider these range of ARM technologies for your next SOC design. I'll stay afterwards if you'd like to talk, and I definitely encourage you to check out the new ARM SOC Design Community online. You can also follow us on Twitter at ARMSOC, or you can follow me as well. Thank you very much for your attention.